With that, what I will do for next talk, and it's a technology talk, we're going to, first let me invite Professor Deepak Gupta first, and along with Dr. Shen. Deepak Gupta is a professor at IIT Kanpur, and he's also the SID India chapter director, and he will introduce Dr. Shen. You can both come on up here. And until the finish of the talk, please stay here. The organizers have some little gifts.
Can I? Please do. I'll just use this. Let me introduce the speaker, and before that, one more time, welcome to you. Extend a welcome to you on behalf of SID India. So I just wanted to give you a brief history of SID India. Also, we started actually in year around 2000 or around that time. The display activity first started in IIT Kanpur and R&D and CRT, the CRT companies those days in India, and we started a center a sample center for display technologies in IIT Kanpur, and that's how we got involved with SID and started the chapter of SID. And in fact, 2006 we organized ASID also in New Delhi in this building itself. But unfortunately, over years, the display activity dwindled down, and we are here today. We are trying to revive that activity again as we see some activity, some sprouts of display manufacturing coming back into this country, and that's why we assembled here to bring this activity back in here. But otherwise, in 2007, we made OLED, full color OLED passive matrix displays in IIT Kanpur itself. We still have that activity, and now we moved on to flexible displays, flexible OLED displays, and R&D is going on that aspect. Now, if I can also take a pot shot, here, I'm also an OLED person, so about that LCD versus OLED debate, I might join you. I recall when CRT industry was doing really well here, around early 2000s, and R&D activity was starting towards flat panel display. This thought was often stated, people I used to interact with, is that, yeah, but that flat panel display time is still far away. And when it happened suddenly, and that CRT industry died away. Now, from being a professor at the technology side, speaking from technology side, I find LCD as fundamentally technically flawed when you kill light at polarizer and you kill light at, color filter again. So in my view, OLED, one should really think about. And, it's fundamentally a good technology. Improvements will happen. With this, let me now introduce this next speaker. I won't take much beyond Dr. Sanjay Shen. He is a professor in Korea University also, and formerly he was CTO of Samsung Displays, director of R&D center there. Also, he's going to be next president of KIDS, which is well-known Korea Information Display Society, and it publishes several journals also. With this introduction, I'd like to invite Professor Shen. He'll speak about technology trends of future displays. Thank you.
Okay, thank you very much for your introduction. Actually, my topic is not very heavy. So, and because actually my title of my talk is Technology Trend for Future Display. Actually, I want to show a movie to you because actually it is almost, it will be sleep time. So I can show you the movie. Okay, I think this slide was the first slide when I 2012. Actually, this is the second slide I gave also at the keynote speech in the same time. Actually, I suggested the three eras of the FFPD market expansion, which are CRT replacement era and innovative replacement era and creation era. Actually, we are facing the creation era because I divided the three and the period among the three, the eras. Actually, the first display growth was brought, the CRT replacement, which was notebook PC, monitor, TV, from starting the 1995. And also the second, actually the display momentum was actually the mobile display, which was smartphone and the table PC from the starting the 2010. And actually the final, actually the display growth momentum will be transformer display, which will be the flexible and the 3D display and also transparent display. You know, actually there are three concepts of the transform, the first one is the physical transform, which will be flexible display. And the second one is the image transform from the 2D to 3D. And the final one, as you showed the transform movie, actually the transform from multifunction from the car to robot. Actually, the window will be replaced. Will be the display in the future. Actually, that's actually why actually I suggested that the creation era for the continuous grow the display industry from starting 2050 is coming now. Actually, this is another slide presented by actually the AUO chairman Paul Fang at the SID this year. Actually, you know, you can see LCD expected to mainstream domain position until you can see the 2023. Okay, so LCD will be actually mainstream, although actually it's time of the 2023. What is the display trend? Actually, the key trend of the display will be not the resolution, but actually the color gamut and the contrast ratio, high dynamic range, and the wide color gamut. You can see here in this figure, actually the preference of the viewer, this is actually the resolution, and this is resolution is almost saturated to high density. By the way, the color gamut will be required to actually the LEC 2020, like BT, actually 2020. Okay, so in this, the display trend, which will be winner between the OLED and QLED. Actually, also micro LED will be another option for future display. Now, actually, I want to discuss with you the display trend, review of the technology strategy between the Samsung display and LG display and Samsung display, because I was from the Samsung display. You know, the actual LG display and Samsung display had always taken different technology, except the transparent display. In the case of the mobile display, Samsung took OLED technology. By the way, LG display took IPS mode, maybe FFS mode, which is IPS cousin of the IPS mode. In the case of the monitor and TV, actually the LG display took the IPS actin liquid crystal mode, and the Samsung took the PVA mode, vertical alignment LCD. And in the case of the curved TV, maybe I think LG Display is focusing on OLED TV. By the way, Samsung is focusing on QLED. So we don't know which will be winners in the future. We will see what happens. Okay, now I want to actually go to the first mobile display. I mean, which technology will be winner between the IPS mode and the PVA mode? Actually, you know that the Inje Chung, the keynote speech in this morning, actually developed the IPS liquid crystal mode. Actually, I developed the PVA mode when I was working at the Samsung display. So actually, you know, the mobile display required touch and the low power consumption. Actually, the vertical alignment, liquid crystal is aligned, liquid crystal just in vertically. When you touch the panel, actually liquid crystal aligned on parallel. And there is the white bridging. Actually, the VA mode cannot be used mobile display. So actually, in this case, actually, the Samsung display, at that time, actually, the LCD vision units at Samsung Electronics. Actually, the LG display already actually developed the IPS mode. By the way, actually, Samsung display didn't want to compete LG display by using the IPS mode. So that's why actually the Samsung display escaped to OLED display. That's the reason, okay? Although actually Samsung display didn't want to go to the OLED, the display, because it is really, the difficult technology. By the way, so you can compare the characteristic of the optic in the two cases, the Galaxy SA, LG G6. So not much difference. Actually, you know, the size and the thickness and the weight and the size, and also spatial resolution. Or the characteristics are not much different. So which one? Okay, this is a comparison of the competition. So you can see there are in the 4 categories which are design and the technology, also cost, differentiation. So the key to replace LCD will be differentiation to flexible display. So in the design, actually no difference between the LCD and OLED, and the technology. Actually, the OLED mobile technology already matured. Actually, the production yield is higher than 90% at the Samsung display. I don't know, it's a Chinese company. The cost, actually the LCD is $25 US for the quadruple high density resolution. By the way, actually the price of the OLED panel is ranging from the $40 to $80. It depends on the rigid or flexible OLED. Also, rigid case is $40. Actually, in the case of the mobile, the price doesn't care. Actually, you know, the actual Galaxy is almost $1,000. The panel, just 2 or 4%. If you see the wow, and then take it. So actually, in the case of the mobile, the price of the panel is not important parameter, okay? And the differentiation, this is the key for the future. Actually, the LCD should be used the BLU unit. So it's not easy for LCD to be foldable, flexible. That's why actually in the case of the mobile display, okay, this is another story. I can show you that actually there are many actually OLED issues when actually Samsung display I started to develop the OLED panel. So you can see here, the resolution is increasing. Actually, in the beginning, Samsung used the RGB strip for Galaxy S2. It's changed the pentile. And then maybe I think also diamond pentile. Actually, it means actually the 3 pixel Actually, 3 pixel is going to the one dot, one image. By the way, pentile technology is following the other color. For example, okay, there is a green, blue color, and you follow the red and green. So that's why actually the 3 pixel is going to the 1 pixel. That's, I think, the key technology to solve all the issues, which were resolution. And you can see that, okay, so wide BM for the fine pitch and also the fine alignment. That's actually the Samsung display made the success by using the pentile technology. Okay, so I want to go to the monitor and TV between the IPS and the PVA. Actually, Samsung display concedes the high contrast ratio and the productivity. By the way, LG display concedes the wide view angle. So it also both company took the different technology. You know that actually the both technology have hidden difficulties, and never technology will be sufficient for the total solution in the future demand or application. It depends on the all application. Okay, now is actually the curved TV. Why actually the LG display is focusing the OLED TV? Also, there is also a hidden problem. Okay, actually the mobile display, yes, IPS technology only can be adapted to the mobile display. By the way, curved display key parameter is radius coverage. Actually, the IPS radius coverage is not enough owing to the color shifter. So actually, that's why I can show you can see here there are two. This is actually the real production. I got the 2 pictures in the market. So the Samsung display radius coverage was 4,000. By the way, radius coverage of the SIPS mode was 702 millimeters. Actually, in the case of the VIA, you can see that this is the VIA. It doesn't matter, it's covered, no problem. But in the IPS case, electrical side is aligned, and then it's tilted, curved, and there is retardation. Actually, there is a color shift of the blue and the yellow in the diagonal axis. That's why you can, okay, this is another. You can see here the problem of the IPS mode on the curved TV was actually yellow shift in diagonal axis, also blue shift. Actually, in the flat TV, actually the compensation film could compensate it. By the way, in the curved TV, actually IPS mode technology cannot have actually the small radius coverage. That's why actually LG display is also escaped to OLED TV. Okay, this is anyway. Which will be winner between the QLED and OLED? We don't know yet. Anyhow, in the tentative solution, LG display took the wider color gamut SUP IPS TV temporarily, and so Samsung display is focusing QLED. Okay, this is the market size of the OLED TV. So in 2020, the market size of the OLED TV is almost 5 million. Actually, total TV size unit is in this year maybe I think 270 million units. So it's a 5 million unit. It's actually less than 5%. Although in 2020. So now actually, this is the key, the topic I want to discuss with you. So I already mentioned actually the LG is focusing on OLED TV. So I took the picture at the CS in this year in Las Vegas. Actually, this is the QLED TV. the next innovation in TV, Q picture, Q style, Q smart. Okay, this is a QLED TV. And also this is the OLED TV. Actually, there was a Doom, actually the tiled 55-inch OLED TV. You can see here. Also, actually, I visited the Fribus of the LG display in Las Vegas. So also there is a picture. All actually the demonstration panels were actually the OLED panels. So I want to actually compare the technical comparison between the QLED OLED. Also in the also 4 categories, also which are the design, image quality, resolution, power consumption, and also technology barrier. So the OLED has merit in design and also image quality, but has technology barrier to overcome. Actually, I compared the optical property from the actual real production, actually the 55-inch ultra high definition LCD TV, actually QLED, and also 55 inches also OLED TV last year, first quarter. So in the case of the design, actually curved TV, also not much difference between the LCD and the OLED. By the way, the image quality, the contrast ratio of the OLED will be 500,000. By the way, the contrast ratio of the LCD is around 7,000. By the way, in the brightness environment, maybe I think the contrast ratio of the OLED will be down. Less than the contrast ratio of the LCD. Also, actually, the switching time. Switching time of the OLED TV is very fast. But OLED cannot take impossible switching technology, holding time. So that's, I think, the switching time is not much difference between the LCD and the OLED. The key will be the wide color gamut. Absolutely. Actually, the OLED, the wide color gamut of OLED is higher than the 110%. By the way, also OLED, QLED is taking the quantum dot pillar, and also the second generation of the QLED. I will show you the slide. And then actually the color gamut will be higher than OLED color gamut, I think. So resolution, actually the technology of OLED almost level up to the LCD resolution. Also power consumption, the LCD power consumption in the case of the 55-inch ultra high definition with 120 frame rate, it will be around actually 150 watt. Also the maximum brightness is 500 candela per meter square. By the way, in the case of the TV, actually the power consumption of OLED is higher, almost 2 times of the power consumption compared to LCD TV. In the case of the mobile display, the power consumption of OLED is lower than the power consumption of LCD power consumption. The key will be the technology barrier. So, the LCD is already matured. In the case of the OLED, actually the lifetime of the blue material and also RGB patterning issues. So, actually nobody can use the mobile smartphone more than 2 years. In the case of the TV, the life of the TV is more than maybe I think 10 years. So nobody knows in the case of the OLED TV about lifetime in the case of the TV. Okay, this is actually the structure of the QLED. Also I'm working at the light polymer. Actually, Light Polymer is a venture company located in South San Francisco. Also, Light Polymer has a few solutions about QLED, alignment layer, and the insert polarizer. Actually, this is the QLED of the second generation. Actually, the key technology of the second generation of the QLED is insert polarizer. And also alignment layer, because actually the process temperature of the currently is higher than the 220 degrees. And actually this temperature will be hot, the quantum dot patterning. That's actually the process temperature of the alignment layer should be less than the 150 degrees. Also, actually, the Samsung Electronics is trying to have two panels for the QLED, which will be actually the linear polarized, LCD shot before the real panel, QLED panel, for the local dimming. In this case, actually, the QLED, contrast ratio of the QLED will be also higher than 500,000. Maybe almost the same contrast ratio of the OLED contrast ratio. That's actually Samsung Electronics is trying to put another LCD shot panel for the local dimming to improve the contrast ratio. Actually, this is a very hot issue. OLED TV can replace the QLED TV. Actually, the LCD was actually developed from starting notebook PC and monitor and TV. In the case of the OLED, actually just a quantum jump from the mobile displays and smartphone to QLED. So there is some actually the problem to have the all infra SCM, supply chain management. So anyhow, the key actually will be the OLED will replace the quantum dot QLED will be cost reduction. Actually, as Professor In-Jae Chung already mentioned, actually the cost of the panel of the OLED is higher than 2.5 times. Actually, the TV, in the case of TV, is totally different between the mobile display. So actually the panel, the portion in TV is almost 60%. It's really different. So what is the solution? Maybe I think for the OLED case. So there are another new application which are automobile display, mirror display, transparent display. Maybe LCD cannot be adapted in this application. Maybe I think this is in my opinion. Actually, the OLED application or automobile mirror, and then actually what can I say? So actually, the amount of the investment OLED in the case of the 100K per month of 8.5 generation is almost 10 billion. By the way, LCD case is 4 billion. So actually the depreciation ratio of the OLED is too high, more than almost 40%. It's big difference. That's why actually the OLED panel cost is very high. Okay, this is an automobile display. Okay. So now actually I want to go to the future display, which will be a transformed display. I already mentioned in the beginning. Actually, they are coming by tentative solution that will be the OLED display, the physical transform, the application, the curved TV, bendable, wearable, foldable. Image transform is actually the 3D display, hologram. In the case of multifunction application, the transparent display, mirror display, automobile display. Also, actually, there are many technology barriers which we should solve as our homework. In the physical transform as a high TFT performance and also high density range, high color gamut, also in thin and durable substrate and the roll-to-roll process, to reduce the cost. Also, actually, the technology for the 3D is very, very difficult. Actually, the key will be the resolution of the 3D will be obtained, will be solved, the high TFT performance and the low RC delay. So I want to go to in detail in the technology. Okay. So the multifunction, actually transparent display, the key will be the transmittance will be higher than 30%. Also color gamut, 70%, high contrast rate higher than the 500. Because actually the transparent display will be used, the environment, actually not the actual backlight source, just environmental source. That's why actually the transmittance will be very important. Okay. Okay, this is a physical transform, flexible display and curved display. Actually, this already came. And also, curved monitor also will come, and also flexible are coming to us, actually driven by the LG display and the Samsung display. This is a monitor, curved monitor is coming, and the curved TV, and also this is also another OLED, tiled OLED. Flexible display. Okay, this is a 3D display. Actually, the technology is not ready. Actually, I don't know when actually 3D stereoscopic display will come. Maybe I think it will not come actually also in 2020. We don't know. Nobody knows. Okay, this is a multifunction transform display. Window will be transformed to display. Okay. Okay. Sorry, I think this is the older. I'm sorry, actually. Also, this is another also slide, also given chairman of the AU at SID this year. The micro LED will a long way to go, although there are many advantage in the in display optical properties. Oops. Samsung. Okay, this is the right one. I'm sorry. This one. This one? Yeah. Yeah. Thank you. Oh, okay. Oh, all right. Actually, there are two actually the LED display, which micro LED display, and also another mini blue LED with LCD panel, also color conversion film. So the first application will be from the mini blue LED because actually in this case it is possible local dimming. And to improve the higher contrast ratio, also low cost. Maybe I think this application will become next year in the production. Okay, this is a summary and conclusion. The first, the issues. Which technology will be the winner for the future display? Solution maybe depends according to the application. OLED display can be LCD display. The mobile, in the case of the mobile, OLED can replace LCD step by step owing to the differentiation. I mean, you know that the flexible and the foldable and the stretchable display. You know, also Apple already started to adapt the OLED panel on iPhone. In this morning, actually, there is the Apple mentioned actually in 2019, the OLED adoption portion will be 100%. And in the monitor and TV, nobody knows, but the actual solution will be from the differentiation and the cost between the QLED and the OLED. This will be the key factor. Transform display, actually tentative solution may be the OLED. We don't know actually OLED will be the forever solution or not. When the micro LED display will come, and it will take more time that you are expecting. But actually mini blue LED will come soon with the color conversion film and LCD panel. Okay, thank you very much for your attention.